All right, hello, you guys. Welcome back to Mr. Litigious class. And in today's lesson, we are going to talk about the law of conservation of mass. The objectives of our lesson today are the following. At the end of the lesson, I would like you to explain how the law of conservation of mass applies to chemical reaction. And number two is you should be able to balance simple chemical reaction. I would like you to look closely the picture of a balance on the right side, the bottom right of the screen. When you are looking at the pans, both at the same height, what does that mean if you have masses you place on both pans? I need you to keep this picture in your mind as we continue to talk about the law of conservation of mass. So, what does the law state? It is simply stating as matter can neither be created nor destroyed. However, it can be rearranged, and that is more specific in a chemical reaction. We want that the mass of the reactants must always be equal to the mass of the products. Last time we were talking about um, uh, the components of a chemical reaction. What are reactants and what are products? Now, thinking about balance, excuse me, everything must be equal, meaning all the components, whether it is from the reactants um, or the products, they have to be equal. And what is this telling us? When matter goes through either a physical reaction or a chemical reaction, the amount of the substances at the beginning of the reaction must be equal to the amount of the mass of the substances at the end of the reaction. So the before and the after must be equal. So, why are we discussing this? Because when we are going to learn about chemical reaction, we have to apply the law of conservation of matter, and we have to prove that in fact matter cannot be created nor destroyed. So let's look at specifically the process and what will happen to the atoms of the elements during chemical reaction. So the atoms in the reactants are rearranged in order to form a new substance, and we call these substances as compounds. But none of the atoms involved in the chemical reaction disappear. In fact, they form a new substance that we call compound, but the atoms are still there. No new atoms are formed. Look at this example right here. A chemical equation is balanced when it reflects the conservation of mass. And if you're looking at the reaction of hydrogen and oxygen to form a molecule of matter, now look at specifically the numbers that are added on the reactant side and the product side. And we are going to talk more about that in the succeeding slides. So this is a simple illustration um, to explain to you and to elaborate more on the idea that um, matter or masses are neither be created nor destroyed during um, chemical reaction. So the same number of each kind of atom must be on the left side of the equation and on the right side of the equation, the reactant sides and the product sides. So, how to do that one? Since we want to meet and achieve the law of conservation of mass during chemical reaction. So our task now is to be able to balance an equation. And in this example right here, it is showing you hydrogen reacting to two atoms of hydrogen is reacting to two atoms of oxygen. And in this reaction, it yields a molecule of water. We know this. We repeated this so many times in our previous discussion. But the question is this chemical equation balanced? So let's just try to look at both sides of the chemical equation if the number of atoms are actually balanced. So let's do an inventory. So in the reactant side, you are seeing two atoms of hydrogen and two atoms of oxygen. Now let's look at the product side. You are looking at two atoms of hydrogen, but there's only one atom of oxygen. So, is this equation balanced? The answer is no, because there's only one atom of oxygen. So, our task now is to make sure that the equation is actually balanced in order to meet the law of conservation of mass. That at the end of the reaction, the number of atoms on the product side must be equal to the number of atoms on the reactant side. So what are we going to do here is to add coefficients in order to balance the number of atoms. All right? So let's look at the atoms of hydrogen on both sides. And we know that they are balanced. Two atoms of hydrogen in the reactant sides, and then we got two atoms of hydrogen in the product side. Now, obviously, the atoms of oxygen in the reactant and product sides, they are not equal. So we got to do something about the atoms of oxygen so that the equation is balanced. So what we're going to do is to add a coefficient. And let's start with the product side. So we added a coefficient of 2. And let's do the calculation. So if we say 2 times the two atoms of hydrogen, that will give us 4 atoms of hydrogen. And then we do the same thing, 2 times 1 atom of oxygen. That will give us 2 atoms of oxygen. So we got it, the side of the product. Now let's move to the side of the reactants. And again, our task here is to balance out the number of atoms on the reactant sides and the product side. So, in this case, hydrogen atoms are not equal, but the oxygen atoms are now equal. So let's work on the hydrogen atoms so that they're equal. And what we're going to do is we are going to add the coefficient of 2 to the reactant, which is hydrogen. And when we do that, hydrogen atoms becomes 4, and then there are already 2 oxygen atoms, so that is already equal. Hydrogen atoms are equal, and then oxygen atoms are equal. So, um, our chemical equation is now balanced, and what does this tell us? It means that mass is in fact conserved during this process. So let's take a look at one more time. So when chemical equations are balanced, the numbers and the kinds of atoms on each side of the reactions um, are equal, especially um, the reactant sides, or particularly the reactant side and the product side. And because atoms are conserved, the mass of the reactants in the chemical reaction, whether in the reactant side and the product side, they have to be equal in order to create that balance of the number of atoms involved in the process. So in this particular graphics, you're seeing that we assign the value of masses of both of these atoms, and we say 2 grams of hydrogen and 38 grams of fluorine, and at the end they balance out with 40 grams equal to 40 grams in the product side. Let us summarize this lesson um, by looking one more time at the definition of the law of conservation of mass, or the law of conservation of matter. So we say that if the amount of matter or mass was not the same before and after the change, so there must be something, um, some other process involved. And let's let's not forget that there is always something like an explanation as to why um, the masses would not turn out to be the same. And what is that? During chemical reaction, some of the mass is converted into either a gaseous substance, or it is converted to a certain form of energy that is being released, just like heat, or just like fumes, or a vapor or a gaseous form. And that those are one of the things that somehow uh, contradict to the law of conservation of mass. But in an ideal cases, all right, in ideal cases, the mass is conserved during the process of chemical reaction. I would like you to click on the link that is provided at the end of this slide, um, because I wanted you to apply what you learned about the law of conservation of matter, or the law of conservation of mass, and also solve the simple um, balancing of equation located on the same worksheet that is provided to you on the link. Enjoy, and email me if you have clarification, or if you have a specific question about balancing of equation.